and welcome to our latest video from New College Science Department covering the core science physics energy topic. There's 9 different types of energy: electrical, chemical like we find in our food or petrol, nuclear, light, kinetic, that's moving energy, sound, thermal, heat, elastic potential like on a rubber band, or gravitational potential like an object high up. Energies can be transferred from one form to another, but according to the conservation of energy, energy cannot be created or destroyed. It can only be transferred. What that means, what goes in must come out. We represent these with a Sankey diagram, where we have the useful energy, what we want, going straight across, and the wasted energy going down. But where does the wasted energy go? Well, it's not lost, it's just transferred into the surroundings. That means it spreads out into the air around us. We can calculate efficiency. Efficiency is the useful out divided by the total in times 100. You will get this on the physics equation sheet, but please remember your percentage sign, otherwise you lose valuable marks in the exam. All types of energy is measured in joules, capital J. It's a proper noun named after Mr. Joule. Moving on to our appliances. All electrical appliances in your home have a power rating. Power is the amount of energy transferred per second. P equals E divided by T. And we measure it in watts. 1,000 watts equals 1 kilowatt. And you need to know this to be able to work out electricity bills. To work out the cost of your electricity, we do the kilowatts times the hours it was turned on for, kilowatt hours, times by the unit price. But where do we get this energy from in the first place? Well, there's lots and lots of different energy resources, renewable and non-renewable. The renewable ones you all know: solar from the sun, wind, geothermal, hydroelectric, tidal, biofuel. All of these will not run out, but all of these can be quite unreliable. Solar only works when the sun's out, wind when it's windy, tidal when the tide's coming in and out. Geothermal only in certain areas where we have radioactive rocks producing heat to turn water to steam. So in our country we still get most of our energy from fossil fuels, that being coal, oil and gas. And we get some through nuclear fission. Nuclear fission has the longest startup time. That means we have to get it going and leave it running to provide our base load. Gas, shortest startup time. So at the break in Coronation Street, when people go and boil their kettles, we rapidly burn gas to release energy to make up for the peak. What's happening in your power station? Well, the fuel. The fuel produces lots and lots of heat. Heat turns water to steam, steam turns a turbine, and turbines charge a generator producing electrical energy that goes out into the national grid. The national grid is just a series of transformers and cables. Step-up transformer increases the voltage, reduces the current, loses less energy, making the whole process more efficient. Step-down transformers reduce the voltage to 230 volts to make it safe for use at home. Cables, they can either be overground or underground. Both have advantages, both have drawbacks. Overground's ugly, but it's easy to fix. Overground could be affected by weather patterns. Underground, really difficult, lots of digging. But it doesn't despoil the landscape. But I've got to make sure it's well insulated, otherwise the ground could become electrified. This is what you need to know to achieve your potential at energy. I'll leave it up for a moment for you to have a look at.